Hello students, I welcome you all for the session of the two-port network problems. So in the case of two-port network problems, so we have undone any of the problem set. So today we are going to start with the very first problem, right? So this is the problem which is being given to you, and before that I'll make sure that I'm going to be with you till the date of your exams, and I'll make sure that I'll clear all the topics with respect to circuits and controls as well as the DSP, right? Yes, and for this particular subject, you're going to make sure that you're going to please to work on all the type of problem that you get in the question paper and that you even get in the textbook also. So don't think that you can clear this subject within 3 days, right? Within 3 days of practice, you can clear this subject because ನೀವು ಏನೇ ಮೆಥಡಾಲಜಿ ಕಲ್ತಿದ್ರು ಏನೇ ಒಂದು ಈ ಲೆಕ್ಕನ ಹೀಗೆ ಮಾಡಬೇಕು ಪ್ರೊಸೀಜರ್ ಕಲ್ತಿದ್ರು ಕೂಡ ಅಲ್ಲಿ ನೀವು ಅಪ್ಲೈ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಬಿಕಾಸ್ ಲೆಕ್ಕ ಡಿಫ್ರೆಂಟ್ ಆಗಿರುತ್ತೆ ರೈಟ್ ದ ಕ್ವೆಶನ್ಸ್ ವಿಲ್ ಬಿ ಡಿಫ್ರೆಂಟ್ ಆಯ್ತಾ ಸೊ ಇವಾಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಫಾರ್ಮುಲಾ ಇರುತ್ತೆ ಸಾರಿ ಜಸ್ಟ್ ಅ ಮಿನಿಟ್ For example, you will be having a formula say and you have the terminologies in the formula, and if the terminologies changes you can easily substitute in the formula, right? ಇವಾಗ RLC terms ಅಂತ ಇರುತ್ತೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಸೊ R ವ್ಯಾಲ್ಯೂ ಏನೋ ಕೊಟ್ಟಿರ್ತಾರೆ, L ಏನೋ ಕೊಟ್ಟಿರ್ತಾರೆ, C ಏನೋ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಅದಕ್ಕೆ ನಿಮ್ಗೊಂದು ಫಾರ್ಮುಲಾ ಇರುತ್ತೆ. ಸೊ ಫಾರ್ಮುಲಾ ನೀವು ಅಪ್ಲೈ ಮಾಡಿಬಿಟ್ಟು ಆ ವ್ಯಾಲ್ಯೂಸ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಫಾರ್ಮುಲಾದೊಳಗೆ ನಿಮ್ಗೆ ಈಸಿಯಾಗಿ ರಿಸಲ್ಟೆಂಟ್ ಸಿಗುತ್ತೆ. ಸೊ ಆ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲ ಇದು. These are not the problems wherein you will get a you're given with some respect to the you're given with some data and you're supposed to apply that data to the formula and then you're supposed to get the resultant. ಆ ತರ ಇಲ್ಲ ಇದು, right? This is something if you even learn the procedure also you will find it difficult because the problems might be very much different and you have to change some parts in the procedure according to the particular problem, right? So ಒಂದು ಲೆಕ್ಕಕ್ಕೆ ನೀವು ಪ್ರೊಸೀಜರ್ ಕಲ್ತಿದ್ರು ಕೂಡ ಆ ಪ್ರೊಸೀಜರ್ ಪ್ರಕಾರ ಅರ್ಥನೇ ನೀವೇನ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ ಲೆಕ್ಕಕ್ಕೆ ಹಾಕ್ಬೇಕಾಗುತ್ತೆ. ಆ ಪ್ರೊಸೀಜರ್ ನ ನೀವು ಆ ಲೆಕ್ಕಕ್ಕೆ ಯಾವ ರೀತಿ ಉಪಯೋಗಿಸ್ಕೋಬೇಕು ಆ ತರ ಉಪಯೋಗಿಸ್ಕೋಬೇಕಾಗುತ್ತೆ, right? That is what is one important agenda. So please do make sure that you're going to work more and more problems with respect to this particular subject itself, right? Now let me start with this particular question, and this is what is your question from another university. So please do make sure that you just find out the question, not the university, because university is not like ಈಗ ನಿಮ್ಗೆ ಯೂನಿವರ್ಸಿಟಿ ಲೆಕ್ಕ ಇಲ್ಲ, ನಿಮ್ಗೆ ಕ್ವಶನ್ ಲೆಕ್ಕ. ಸೊ ನಿಮ್ಗೆ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೋ ಆ ತರದೆಲ್ಲ ವರ್ಕೌಟ್ ಮಾಡ್ತೀರಾ. ಸೊ ಇಟ್ ನಾಟ್ ಟು ಲೈಕ್ look at with respect to the university. Please do try to look at with respect to the question and try to solve more and more questions without fail, right? Yeah. So this is what is one important question, and you're supposed to find out the y and z parameter as told. I've already told that you're supposed to practice on y and z parameter theory as well as problem, because y and z parameter theory as well as problems are given many a times, right? So ದಯವಿಟ್ಟು ಕ್ವೆಶ್ಚನ್ ಪೇಪರ್ ಇದಕ್ಕೆ ನೋಡಿ ಅಂತ ಹೇಳೋದು. ಸೊ ನೀವು ಸುಮ್ಮನೆ ಬ್ಲಾಂಕ್ ಆಗಿ ಓದಿ, ಡೋಂಟ್ ವೇಸ್ಟ್ ಯುವರ್ ಟೈಮ್, ರೈಟ್? ಇಟ್ಸ್ ಅ ಟೈಮ್ ವೇಸ್ಟ್ ಇಫ್ ಯು ಸ್ಟಡಿ ಇನ್ ಬ್ಲಾಂಕ್, ರೈಟ್? ಏನು ಗೊತ್ತಿಲ್ಲ, ನಾನು ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಏನಿದೆಯೋ ಆರ್ಡರ್ಲೇ ಹೋಗ್ತೀನಿ. ನಾನು ಫಸ್ಟ್ ಟಾಪಿಕ್ ತಗೋತೀನಿ, ಅದ್ರ ಮೇಲೆ ವರ್ಕ್ ಮಾಡ್ತೀನಿ, ಸೆಕೆಂಡ್ ಟಾಪಿಕ್ ತಗೋತೀನಿ, ಅದ್ರ ಮೇಲೆ ವರ್ಕ್ ಮಾಡ್ತೀನಿ. ಹಾಗೆ ಮಾಡ್ಬೇಡಿ. ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಟಾಪಿಕ್ ಇದೆಯೋ ಅಷ್ಟು ಟಾಪಿಕ್ ಅಲ್ಲೂ ಮುಕ್ಕಾಲ್ ಭಾಗ ಟಾಪಿಕ್ ಇಂದಾರು ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ಕ್ವಶನ್ಸ್ ಬಂದಿರುತ್ತೆ. ಅದರಲ್ಲಿ ಕೆಲವೊಂದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ಫಸ್ಟ್ ಅದನ್ನ ಗುರ್ತು ಮಾಡ್ಕೊಂಡು ಓದ್ಕೊಳ್ಳಿ. ಆವಾಗ ನಿಮ್ಗೆ ಅಕಸ್ಮಾತ್ ಅದೇ ರಿಪೀಟೆಡ್ ಆಗಿ ಬಂದಾಗ ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಸೊ ಆ ತರ ನೋಡುವಂತಹ ಒಂದು ಕೆಲಸವನ್ನ ದಯವಿಟ್ಟು ಮಾಡಿ, ಆಯ್ತಾ? ಸೊ ದಯವಿಟ್ಟು ಆ ತರದೊಂದು ಕೆಲಸನ ಮಾಡಿ, ಇಲ್ಲಾಂದ್ರೆ ನಿಮ್ಗೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ ಆ ತರ ಮಾಡ್ಕೊಂಡು ಆಮೇಲೆ ಏನ್ ಉಳಿಯತ್ತೆ ವಿಚ್ ಇಸ್ ಅನ್ಇಂಪಾರ್ಟೆಂಟ್, ಯು ಫೈಂಡ್ ಇಟ್ ವಿಚ್ ಹ್ಯಾವ್ ನಾಟ್ ಕಮ್ ಇನ್ ದ ಕ್ವಶನ್ ಪೇಪರ್, ಅದನ್ನ ಲಾಸ್ಟ್ ಗೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ, ಅದನ್ನು ಬಿಡ್ಬೇಡಿ, ಅದನ್ನ ಲಾಸ್ಟ್ ಗೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಸೊ ಈ ರೀತಿ ಓದ್ಬೇಕಾಗುತ್ತೆ. ಡೋಂಟ್ ಸ್ಟಡಿ ಇನ್ ಬ್ಲಾಂಕ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎನಿ ಆಫ್ ದ ಸಬ್ಜೆಕ್ಟ್ಸ್. ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಎ ಸಿಲೆಬಸ್ and looking at the syllabus you are going to practice. No, that is not a very good habit, right? ಫಸ್ಟ್ ನಿಮ್ಗೆ ಕ್ವಶನ್ ಪೇಪರ್ ಇಂದಾನೆ ಸ್ಟಾರ್ಟ್ ಆಗೋದು ನಿಮ್ ಕೆಲಸ. ಕ್ವಶನ್ ಪೇಪರ್ ನೋಡ್ತೀರಾ, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಎಲ್ಲ ಒಂದ್ ಲಿಸ್ಟ್ ಹಾಕೊಳ್ತೀರಾ, ಅದು ಯಾವ ಟಾಪಿಕ್ ಇಂದ ಬಂದಿದೆ ಅಂತ ಲಿಸ್ಟ್ ಹಾಕೊಳ್ತೀರಾ, ಆ ಟಾಪಿಕ್ಸ್ ನ ಹೆಚ್ಚು ವರ್ಕೌಟ್ ಮಾಡ್ತೀರಾ, ಆಮೇಲೆ ನೀವು ಉಳಿಯೋ ಟಾಪಿಕ್ ಬರಬೇಕಾಗುತ್ತೆ. ಇಫ್ ಯು ಡೂ ದಿಸ್ ದೆನ್ ಯು ವಿಲ್ ಬಿ ಸಮ್ ವಾಟ್ ರಿಲೀವ್ಡ್. ಸೊ ಈ ತರ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ, ಸೊ ನಾನು ಈ ತರ ಕ್ವಶನ್ಸ್ ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದೀನಿ, ಸೊ ಏನೇನು ಉಳಿದಿದೆ ಅದನ್ನ ಮಾಡ್ಬೇಕು ಅನ್ನೋದು ನಿಮ್ ತಲೆಗೆ ಬರುತ್ತೆ. ಸೊ ನಿಮ್ಗೆ ಹೆಚ್ಚು ರಿಲೀಫ್ ಬೇಕು, ನಿಮ್ಗೆ ಹೆಚ್ಚು ಫ್ರೀ ಬೇಕು ಅಂತ ಅನ್ನೋದಾದ್ರೆ ಸೊ ಈ ತರ ಒಂದು ಮೆಥಡಾಲಜಿನ ಫಾಲೋ ಮಾಡಿ. ದಯವಿಟ್ಟು ಬೇರೆ ಯಾವ ಮೆಥಡಾಲಜಿಗೂ ಹೋಗ್ಬೇಡಿ, ಬಿಕಾಸ್ ದಟ್ ಮೇಕ್ಸ್ ಯು confused and that makes you more stressful and that makes you a waste of time. ರೈಟ್. ಸೊ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡೋಕ್ಕಿಂತ ಈಸಿಯಾಗಿ ವರ್ಕೌಟ್ ಮಾಡಿ, ಸ್ಮಾರ್ಟಾಗಿ ವರ್ಕೌಟ್ ಮಾಡಿ. ಏನಕ್ಕೆ ನೀವು 8 ಅವರ್ಸ್ 9 ಅವರ್ಸ್ ವೇಸ್ಟ್ ಮಾಡಿ ಮಾರ್ಕ್ಸೇ ತಗೊಂಡಿಲ್ಲ ಅಂದರೆ ಇಟ್ಸ್ ಅ ವೇಸ್ಟ್, ರೈಟ್. ಯಾರೋ 8 ಅವರ್ 9 ಅವರ್ ಓದಿದ್ರು, ಅವರು ಮಾರ್ಕ್ಸೇ ತಗೊಂಡಲ್ಲ, ಅವ್ರಿಗೆ ಕಡಿಮೆ ಮಾರ್ಕ್ಸ್ ಬಂದಿದೆ, ಅಷ್ಟೊಂದು ಓದ್ತಿದ್ರು, ಯಾಕೆ ಕಮ್ಮಿ ಮಾರ್ಕ್ಸ್ ತಗೊಂಡಿದ್ದಾರೆ ಅಂತಂದ್ರೆ ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಯು ಹ್ಯಾವ್ ನಾಟ್ ಸ್ಟಡಿಡ್ ಪ್ರಾಪರ್ಲಿ ಅಷ್ಟೇ. ನಿಮ್ಮ ಮೆಥಡಾಲಜಿ ಆಫ್ ಸ್ಟಡಿ ಪ್ರಾಪರ್ ಇಲ್ಲ. ನೀವು ಸುಮ್ಮನೆ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡಿದ್ರೆ ಹ್ಯಾವ್ ನಾಟ್ ಸ್ಟಡಿಡ್ ಇನ್ ಎ ಪ್ರಾಪರ್ ಮ್ಯಾನರ್, ನಾರ್ ಯು ಹ್ಯಾವ್ ನಾಟ್ ರಿಟನ್ ದ ಆನ್ಸರ್ ಇನ್ ಎ ಪ್ರಾಪರ್ ಮ್ಯಾನರ್. ಆನ್ಸರ್ ರೈಟಿಂಗ್ ನೀವು ನೀಟಾಗಿ ಬರ್ದಿರಲ್ಲ, ಇಲ್ಲ ಅಂತಂದ್ರೆ ನೀವು ಸರಿಯಾಗಿ ಓದೇ ಇರಲ್ಲ. ಕೆಲವರು ಸರಿಯಾಗಿ ಓದಿದ್ರು ಆನ್ಸರ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಿರಲ್ಲ. ಸೊ ಎಲ್ಲಾ ತರ ರೀಸನ್ಸ್ ಇರೋದ್ರಿಂದ, ಸೊ ಪ್ಲೀಸ್ ಟು ಮೇಕ್ ಶ್ಯೂರ್ ದಟ್ ಯು ಬ್ಯಾಲೆನ್ಸ್ ದ ಬೋತ್. ಯು ಸ್ಟಡಿ ಇಟ್ ಇನ್ ಅ ಕ್ಲೀನ್ ಮ್ಯಾನರ್, ಯು ರೆಪ್ರೆಸೆಂಟ್ ಇಟ್ ಇನ್ ಅ ಕ್ಲೀನ್ ಮ್ಯಾನರ್, ಯು ಗೆಟ್ ಅ ಗುಡ್ ಮಾರ್ಕ್ಸ್, ರೈಟ್. ಸೊ ಅದಕ್ಕಾಗಿ ನಿಮಗೆ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಬಂದಿದೆ. ಐ ಆಮ್ ರಿಪೀಟೆಡ್ಲಿ ಟೆಲಿಂಗ್ ಇಟ್ ಯು ಅಗೇನ್. ಪ್ಲೀಸ್ ಟು ಗೋ ಟು ದ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್, ಯು ಗೆಟ್ ಇಟ್ ಎವ್ರಿವೇರ್, ರೈಟ್. ಎಲ್ಲಾ ಕಡೆನೂ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ನಿಮಗೆ ಸಿಗ್ತಾ ಇದೆ. ಸೊ ದರ್ ಆರ್ ಮೆನಿ ವಿಡಿಯೋ ಗ್ರೂಪ್ಸ್ ವಿಚ್ ಇಸ್ ಶೇರಿಂಗ್ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಫಾರ್ ಯು. ಸೊ ಅದನ್ನ ದಯವಿಟ್ಟು ಉಪಯೋಗಿಸ್ಕೊಳ್ಳಿ, ಅದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ, ಅದನ್ನೇ ಫಾಲೋ ಮಾಡಿ. ಸೊ ನಿಮ್ಗೆ ಯಾಕೆ ಮಾರ್ಕ್ಸ್ ಬರಲ್ಲ ಅಂತ ನಾನು ನೋಡ್ತೀನಿ, ರೈಟ್. ಈವನ್ ವೆನ್ ವಿ ವರ್ ಸ್ಟಡಿಂಗ್ ವಿ ಡಿ ನಾಟ್ ಹ್ಯಾಡ್ ಅನ್ ಐಡಿಯಾ ನಾವ್ ಹೆಂಗ್ ಬರೆದ್ರೆ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ ಅವರು, ನಾವ್ ಯಾವ ರೀತಿ ಬರಿಬೇಕು ಅಂತ ನಮಗ್ ಗೊತ್ತೇ ಇಲ್ಲ. ವಿ ವರ್ ಜಸ್ಟ್ ಸ್ಟಡಿಂಗ್ ಅಂಡ್ ರೈಟಿಂಗ್ ಇಟ್. ಬಟ್ ಇವಾಗ ನಿಮ್ ಕೈಯಲ್ಲೇ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಇದೆ ಅಲ್ವಾ, ನಿಮ್ ಕೈಲೇ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಇರೋದು, ನಿಮ್ಗೆ ಎಷ್ಟು ಲಾಭ ಅನ್ನೋದು ನೀವೇ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ನೀವು ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟಾಪಿಕ್ ಇಂದ ಒಂದು ಕ್ವಶನ್ ತಗೊಂಡು ಆ ಕ್ವಶನ್ಗೆ ಯಾವ ತರ ಆನ್ಸರ್ ಬರೀಬೇಕು ಅಂತ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆಲ್ಲ ಫ್ರಮ್ ದ ಸ್ಕ್ರಾಚ್ ಟು ದ ಅಡ್ವಾನ್ಸ್ಡ್ ಎಲ್ಲ ಸಿಗುತ್ತೆ ಅಲ್ವಾ, ಫ್ರಮ್ ದ ಬಿಗಿನಿಂಗ್ ಟು ದ ಎಂಡ್ ಎಲ್ಲಾನು ಸಿಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ನೀವು ಅದನ್ನ ನೋಡ್ಕೊಂಡು ಅದೇ ರೀತಿ ನೀವು ಆ ಕ್ವಶನ್ಗೆ ಆನ್ಸರ್ನ ಬರೆದ್ರೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ, ಸೊ ನಿಮ್ಗೆ ಈಸಿಯಾಗಿ ಸಿಗುತ್ತೆ ಮಾರ್ಕ್ಸು. ಸೊ ಇವಾಗ ನಾನು ಝೆಡ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಇದು ಝೆಡ್ ಪ್ಯಾರಾಮೀಟರ್ ಕಾನ್ಸೆಪ್ಟ್. ಸೊ ವೈ ಅಂಡ್ ಝೆಡ್ ಪ್ಯಾರಾಮೀಟರ್ ಕಾನ್ಸೆಪ್ಟ್, ಈ ತರ ಕ್ವಶನ್ಗೆ ನಾನು ಯಾವ ರೀತಿ ವರ್ಕೌಟ್ ಮಾಡಬೇಕು ಮತ್ತೆ ಯಾವ ರೀತಿ ವರ್ಕೌಟ್ ಮಾಡಿದ್ರೆ ನನಗೆ ರಿಸಲ್ಟ್ ಸಿಗುತ್ತೆ ಅನ್ನುವಂಥದ್ದನ್ನ ನಾನು ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಮುಖಾಂತರ ತಿಳ್ಕೊಬೋದಲ್ವಾ. ಸೊ ಐ ಶೋಕೇಸ್ ಯು ದ್ಯಾಟ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ ಇಟ್ ಸೆಲ್ಫ್, ಬಿಕಾಸ್ ಇಲ್ಲೇ ಗೊತ್ತಾಗ್ಬಿಡ್ಲಿ ನಿಮ್ಗೆ, ಯಾಕೆಂದ್ರೆ ನಾವು ಯಾವ್ದನ್ನು ನಿಮ್ಗೆ ಮುಚ್ಚುಮರೆ ಮಾಡದೇ ಇರಲ್ಲ. ಸೊ ಐ ಜಸ್ಟ್ ಶೋ ಯು ಈಚ್ ಅಂಡ್ ಎವ್ರಿಥಿಂಗ್. ಸೊ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ನಮ್ಮ ಬೋನಸ್ ಅಂತಾನೆ ಹೇಳ್ಬೋದು, ನಮ್ಗಂತಲ್ಲ, ಇಟ್ಸ್ ಬೋನಸ್ ಫಾರ್ ಯು ಪೀಪಲ್, ರೈಟ್. ಸೊ ಬರೀ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ನೋಡೋದಲ್ಲ, ಅದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು, ಸೊ ಅದ್ರಲ್ಲಿ ಹೆಂಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಷ್ಟೆಷ್ಟಿಗೆ ಯಾವ ಒಂದು ಪಾರ್ಟ್ಗೆ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಅನ್ನ ಹಾಕಿದ್ದಾರೆ, ಸೊ ನಾವ್ ಎಷ್ಟು ವರ್ಕೌಟ್ ಮಾಡ್ಬೇಕು ಅನ್ನೋಂಥದ್ದು ಸೊ ನಮ್ಗೆ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ದಯವಿಟ್ಟು ನೀವೇನ್ ಮಾಡ್ತೀರಾ ಅಂತಂದ್ರೆ, ದಯವಿಟ್ಟು ಚೆನ್ನಾಗಿ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಉಪಯೋಗಿಸ್ಕೊಳ್ಳಿ. ಸೊ ನಾವು ಅದನ್ನ ಬೋನಸ್ ಆಗಿ ಇಟ್ಕೊಂಡು ನಿಮ್ಮೆಲ್ಲರಿಗೂ ನಾವು ಅದನ್ನ ಕ್ಲೀನ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಕೊಡ್ತಾ ಇದೀವಿ. ಸೊ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಕೊಡ್ತಾ ಇರೋದ್ರಿಂದ ಸೊ ನಿಮ್ಗೂ ಸ್ವಲ್ಪ ಅರ್ಥ ಆಗುತ್ತೆ ಅಂತ ನಾನು ಅನ್ಕೊಂಡಿದ್ದೀನಿ, ಅಂಡ್ ಅದನ್ನ ನೀವು ಫಾಲೋ ಮಾಡ್ತೀರಾ ಅಂತ ನಾನು ಹೇಳ್ತಾ, ಸೊ ಐ ಜಸ್ಟ್ ಮೇಕ್ ಶೋರ್ ದಟ್ ಐ ಮೇಕ್ ಯು ಅ ವೆರಿ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋ ಸ್ಕೀಮ್ ಆಫ್ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಫಾರ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್. ಸೊ ಝೆಡ್ ಪ್ಯಾರಾಮೀಟರ್ ನಾವ್ ಏನೇನ್ ಹೇಳ್ಕೊಡ್ತೀವಿ ಈಗ, ಝೆಡ್ ಅಂಡ್ ವೈ ಪ್ಯಾರಾಮೀಟರ್ ಥಿಯರಮ್ ಆಗಿರ್ಬೋದು, ಅಥವಾ finding out the z parameters with what I can say, finding out the other parameters in terms of one parameter. So finding out y parameter in terms of other parameter, finding out z in terms of other parameter. So ಇವೆಲ್ಲ ಹೇಳಿದ್ದೀನಿ. ಸೊ ಇದದ್ದು ಹೇಗೆ ನೀವು ಬರೀಬೇಕಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕು ಅಂತ ತೋರಿಸ್ಕೊಡ್ತೀನಿ. ಸೊ ದಯವಿಟ್ಟು ಅದನ್ನು ನೋಡ್ಕೊಳ್ಳಿ ಅಂತ ಹೇಳ್ತಾ ವಿಲ್ ಜಸ್ಟ್ ಕಮ್ ಟು ದ ಪ್ರಾಬ್ಲಮ್. ಸೊ ದೀಸ್ ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ಸ್, ಬಿಕಾಸ್ ಇವನ್ನೆಲ್ಲ ನಾವು ಒಂದೊಂದು ವಿಡಿಯೋದಲ್ಲೂ ಹೇಳ್ತಾ ಇದ್ರೆ ಸೊ ಹೊಸಬ್ರು ಬರೋರಿಗೂ ಗೊತ್ತಾಗತ್ತೆ, ಅವರು ಇದನ್ನ ಖಂಡಿತ ಫಾಲೋ ಮಾಡ್ತಾರೆ. ಸೊ ಅವಾಗ ಅವರಿಗೂ ಸ್ವಲ್ಪ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ನಾವು ಜಸ್ಟ್ ಬರೀ ವಿಡಿಯೋ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ ಸೊ ಯಾರು ಹೊಸಬ್ರು ನೋಡುವಾಗ ಅವ್ರಿಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ ಗಳು ಸಿಕ್ಕೋಲ್ಲ. ಇವಾಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಎನಿಬಡಿ ಇಸ್ ಫೈಂಡಿಂಗ್ ದಿಸ್ ವಿಡಿಯೋ ಡ್ಯೂರಿಂಗ್ ದ ಟೈಮ್ ಆಫ್ ಎಕ್ಸಾಮ್ and if anybody sees our introduction to this particular video, so ಅವ್ರಿಗೆ ಒಂಚೂರು ಹೆಂಗ್ ಓದ್ಬೇಕು ಅನ್ನೋ ಟ್ರಿಕ್ಸ್ ಗೊತ್ತಾಗುತ್ತಲ್ವಾ, ಅದನ್ನ ದೇ ಕ್ಯಾನ್ ಅಪ್ಲೈ ಟು ಎನಿ ಅದರ್ ಸಬ್ಜೆಕ್ಟ್ ವಿತ್ ಆರ್ ಸ್ಟಡಿಂಗ್. ಸೊ ಆ ತರ ಒಂದು ಉಪಯೋಗ ಆಗ್ಲಿ ಅನ್ನೋ ಒಂದು ಕಾರಣಕ್ಕೆ ನಾವು ಇದನ್ನ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ now let me start with this particular problem. ಸೊ ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿ ಮುಗಿಸ್ಕೊಡ್ತೀನಿ, ಬಿಕಾಸ್ ದಿಸ್ ವೆರಿ ಮಚ್ ಸಿಂಪಲ್ ಅಂಡ್ ಈಸಿಯರ್, ಅಂಡ್ ಪ್ಲೀಸ್ ಟು ಮೇಕ್ ಶೋರ್ ದಟ್ ಯು ವಾಚ್ ದಿಸ್ ವಿಡಿಯೋ ವಿತೌಟ್ ಫೇಲ್. ಸೊ ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ವಿಡಿಯೋ ಬಂದು ಮಾಡೆಲ್ ನಂಬರ್ 1 ಗೆ ಖಂಡಿತ ಕನೆಕ್ಟ್ ಆಗಿದೆ, ಬಿಕಾಸ್ you have to study model number 1 without fail, right. model number 1 ನಲ್ಲಿ ಪಾರ್ಟ್ ಏನ ಕಲ್ತ್ಕೊಂಡ್ರು ಸಾಕು ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನ ಮಾಡಬಹುದು. ಬಿಕಾಸ್ ಏನಕ್ಕೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ನಿಮ್ಗೆ ಐ ಶೋ ಯು ವೈ. ಸೊ ದಿಸ್ ಇಸ್ ಹಿಯರ್ v1 is equal to z11 i1 plus z12 i2 and v2 is equal to z21 i1 plus z22 i2, which is your z parameter, correct. ಸೊ ಇವಾಗ ನಮ್ಗೆ we want z11 and z21 now. So what is z11? Z11 is nothing but when you make your I2 is equal to 0, so you get it as Z11 is equal to V1 by I1, and you when you what I can say, when you take your I2 is equal to 0, your Z21 will become equal to V2 by I1, right. ಇವಾಗ ನಾವು I2 0 ಮಾಡ್ತೀವಂತೆ. where is I2? my I2 is present over here and I make this I2 as 0. So therefore I get this resultant circuit when I make my I2 is equal to 0. So ಈ resultant circuit na ನಾನು ಹೇಗೆ solve ಮಾಡಬೇಕು? I have to solve by using the methodologies which is present in model number 1 part A, which is nothing but a mesh analysis, nodal analysis, a current divider rule, voltage divider rule, star to delta or delta to star transformation, and your normal, that is V is equal to IR or I is equal to V by R. This is what is supposed to follow. ಇಷ್ಟನ್ನ ನೀವು follow ಮಾಡಲೇಬೇಕಲ್ವಾ ಇಲ್ಲೂನು. So that is why the first module is very much important. First module ಚೆನ್ನಾಗಿ ಕಲ್ತ್ಕೊಳ್ಳಿ, ಆವಾಗ ಈ module ಸುಲಭ ಆಗುತ್ತೆ. Right? I just tell you that. Exclude part B. Part B ಇಲ್ಲ, ಬರೀ part A ನಲ್ಲಿರುವಂತ ಕಾನ್ಸೆಪ್ಟ್ ಕಲ್ತ್ಕೊಂಡ್ರೆ ಈ ಒಂದು Z transformation, that is module 2 part A ನ ಚೆನ್ನಾಗಿ ಮಾಡ್ಕೊಳ್ಬಹುದು. Right? Yes. So let me come to that now. So if you can see here, so they will ನೋಡೋದಾದ್ರೆ ಏನಾಗ್ತಾ it is nothing but 1 2 2. So right, you have got this in terms of, just a minute, I'm sorry. So ದಯವಿಟ್ಟು ಇದನ್ನ ಕ್ಲೀನ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. So you've got this in terms of delta and you are going to convert it into star. So now here we are going to see how to convert a delta into star, right? ಈಗ ಏನಾಗಿದೆ, ನಿಮ್ಮ ಸಿಲೆಬಸ್ ನಲ್ಲಿ delta to star conversion ಕೇಳೇ ಇಲ್ಲ and ನಿಮ್ಮ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಅದು ಇಲ್ಲವೂ ಇಲ್ಲ. So that is why we have eliminated that topic. But ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ನಿಮಗೆ delta to star conversion ಮೇಲೆ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಬಂದಿರೋದ್ರಿಂದ, so you are supposed to know how to convert delta to star and star to delta, right? That is what is supposed to see, because ನೀವು ಅದನ್ನ ಕಲ್ತ್ಕೊಂಡಿದ್ರೆ you can just apply it over here. No need to take it into that much seriousness. So simple ಆಗಿ ತಿಳ್ಕೊಳ್ಳಿ, ಸಿಂಪಲ್ ಆಗಿ ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿ ಸಾಕು, ಯಾವುದೇ ರೀತಿ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಬೇಡ. You don't get a separate question on that. ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ನಿಮ್ಮ ಡಯಾಗ್ರಾಮ್ ಬಂದಿರೋಂಥದ್ದು ಡೆಲ್ಟಾ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಡೆಲ್ಟಾ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಬಂದಿದೆ ಅಂಡ್ ಅದನ್ನ ನೀವು ಸ್ಟಾರ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕು ಅಷ್ಟೇ. ನಿಮ್ಗೆ ಇಲ್ಲಿರೋ ಕೆಲಸ ಬಿಟ್ರೆ ನಿಮ್ಗೆ ಅದಕ್ಕೆ ಅಂತ ಸಪರೇಟ್ ಆಗಿ ಪ್ರಾಬ್ಲಮ್ ಕೊಡಲ್ಲ. ಸೊ ದಯವಿಟ್ಟು ಅದನ್ನ ಅಷ್ಟು ತಲೆಗೆ ಹಚ್ಕೊಳ್ಳದೆ, ಪ್ಲೀಸ್ ಟು ಸಿ ಹೌ ಟು ಕನ್ವರ್ಟ್ ಎ ಡೆಲ್ಟಾ ಟು ಸ್ಟಾರ್ ಅಂಡ್ ಸ್ಟಾರ್ ಟು ಡೆಲ್ಟಾ. And please do make sure that you're going to learn some tips and tricks with respect to this, right? So now before that, so how to convert a delta to star? So a delta to star, first if you want to find out R1, which is nothing but RA into RB whole divided by RA plus RB plus RC. This is you have convert delta to star. You are supposed to use this formula, right? What is R1, R2 and R3? That's the equivalent resistances in the terms of star, right? Equivalent resistance in terms of star, right? Yeah. So what is R2? So here R2 is nothing but RB into RC whole divided by RA plus RB plus RC, right? Yeah. Yes. So after writing this, I'll give you some time to take a screenshot, because I'm going to erase this. So because I want this diagram what is there on the PDF, right? Yeah. So what is R3? Here R3 is nothing but, so that is equal to RC RA whole divided by RA plus RB plus what? RA plus RB plus RC. So this is what is one important thing to you. And now what you're supposed to do is you're going to substitute all the values over there and you're going to get the resultant, right? But now along with this, we are also going to learn how to convert your star to delta, right? We learned how to convert your delta to star, but we also have to know how to convert a star to delta, as well as how to convert a delta to star or star to delta when you have a value, when you have the same values of resistances, right? This is your conversion of delta to, just a minute, delta to star, right? Yes, delta to star. Okay. So now here we are supposed to now convert star to delta, right? So star to delta convert ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? ಈ ಒಂದು ಪ್ರಾಬ್ಲಮ್ಗೆ ನಾವು delta to star ಉಪಯೋಗಿಸೋದು. ಬಟ್ ನಿಮಗೆ star to delta ನ ತಿಳ್ಕೊಳ್ಳಿ, and along with that you learn how to convert star to delta or delta to star if you have the same value of resistances, right? Yeah. What is the star to delta formula? you have to get RE, RB and RC, right? Your resistances of star after you convert it from delta, it is R1, R2 and R3. So ನೀವು ಡೆಲ್ಟಾ ಒಂದು ಸ್ಟಾರ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದಾಗ ಸೊ ಸ್ಟಾರ್ ಇರುವಂತ ರೆಸಿಸ್ಟೆನ್ಸಸ್ ನಾವು R1, R2 ಮತ್ತೆ R3 ಅಂತ ಹೇಳ್ತೀವಿ. ಮತ್ತೆ ನೀವು ಸ್ಟಾರ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಟು ಡೆಲ್ಟಾ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ನೀವು ಮಾಡಿದಾಗ ಸೊ ಡೆಲ್ಟಾ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಅಲ್ಲಿ ಇರುವಂತ ರೆಸಿಸ್ಟೆನ್ಸಸ್ಗೆ ನಾವು RE, RB, RC ಅಂತ ನೇಮ್ ಮಾಡ್ತೀವಿ. Right? What is RA? Your RA is nothing but R1 R2 plus R2 R3 plus what? Plus R3 R1, right? ಸೊ ಇವಾಗ ನಿಮ್ಗೆ ಅಷ್ಟು ತಲೆ ಹೋಗುವಂಥದ್ದು ಇಲ್ಲೇನು ಇಲ್ವೇ ಇಲ್ಲ. ಸೊ ಜಸ್ಟ್ ಈ ಫಾರ್ಮುಲಾನ ದಯವಿಟ್ಟು ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ನಾವು ಏನಕ್ಕೆ ಇದನ್ನ ಹೇಳ್ತಾ ಇದೀವಿ ಅಂತಂದ್ರೆ ಸೊ ನಿಮ್ಗೆ ಇದ್ರಲ್ಲಿ ಯಾವ್ದು ಪ್ರಾಬ್ಲಮೇ ಬರಲ್ಲ. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಇಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಆದ್ಮೇಲೆ ಆ ತರದೊಂದು ಸ್ಟ್ರಕ್ಚರ್ ಬಂದಿರೋದು. ಸೊ ಅದಕ್ಕೆ ನಾವು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಷ್ಟೇನೆ. ಬಟ್ ನಿಮ್ಗೆ ಏನು ಅಂತಂದ್ರೆ ನಿಮ್ಗೆ ಸಪ್ರೇಟ್ ಆಗಿ ಯಾವುದೇ ತರದ ಪ್ರಾಬ್ಲಮ್ ಕೊಡಲ್ಲ. ಸೊ ದಯವಿಟ್ಟು ಅದ್ರ ಬಗ್ಗೆ ಯೋಚನೆ ಮಾಡ್ದೇನೆ ದಯವಿಟ್ಟು ವರ್ಕೌಟ್ ಮಾಡಿ. Don't think about that and just learn the formula and just try to apply it and get the resultant, right? ಇದೇನ್ ಸಪ್ರೇಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲ, ಸಪ್ರೇಟ್ ಆಗಿ ಪ್ರಾಬ್ಲಮ್ ಕೊಡಲ್ಲ ನಿಮ್ಗೆ ಇಂತಿಷ್ಟು ಮಾರ್ಕ್ಸ್ಗೆ ಅಂತ. ಸೊ ಅದಕ್ಕೆ ದಯವಿಟ್ಟು ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡಿ. ದಿಸ್ ಇಸ್ ಯರ್ ಆರ್, only just learn the formula. This is your R2. And what is RB? For RB, in place of 40, you are going to write it as R3. And for RC, in place, you are going to write it as R1, right? So RB go ashtene. It is R1, R2 plus R2, R3 plus R3, R1. This particular thing is same for all. So divided by will change. What happens in the case of divided by? For RA, it is R2. For RB it is R3 and for RC it is R1, right? The top one, that is R1 R2 plus R2 R3 plus R3 R1 remains the same for all the three, right? So now a question arises for you, how to solve the um, star to delta network or delta to star network if you have a same resistance, right? For example, ಈಗ ಇಲ್ಲಿ 1 to 2 ಇದೆ ಅಲ್ವಾ? So here 2 and 2 is the same. If I consider this resistance is also the same. If I consider that this resistance is 2, then what happened? All the three resistances are the same. So in that case, so you are going to write your R star is equal to, what is your R star? R delta by 3, right? R star is R delta by 3. R star is R delta by 3 and R delta is equal to 3 times of R star, right? Okay, yeah. So this is what is supposed to learn, right? Ishtu ನೀವು ನೆನ್ಪಿಟ್ಕೊಂತೀರಾ ಅಂದ್ರೆ if you learn this much you can easily crack your exams, right? ನಿಮ್ಗೆ ಏನಕ್ಕೆ ಅಂದ್ರೆ ಯಾವುದೇ ರೀತಿ ಕ್ವಶನ್ ಬರಲ್ಲ, ನಿಮ್ಗೆ ಸಿಂಪ್ಲಿಫೈ ಆಗಿರಕ್ ಮಾತ್ರ ಬಂದಿರೋದು ಆ ಸಿಚುಯೇಷನ್ ಅಷ್ಟೇ. ನಿಮ್ಗೆ ಅದಕ್ಕೆ ಅಂತ ಸಪ್ರೇಟ್ ಆಗಿ ಕ್ವಶನ್ ಕೊಡಲ್ಲ. ಕೊಡೋಂಗಿರೋದು ಫಸ್ಟ್ ಮಾಡಲಲ್ಲೇ ಈ ಟಾಪಿಕ್ ಬರಬೇಕಾಗಿತ್ತು, ನಿಮ್ಮ ಸಿಲೆಬಸ್ಗೆ ಇನ್ಕ್ಲೂಡ್ ಮಾಡಿಲ್ಲದ ಕಾರಣ. ಸೊ ಪ್ಲೀಸ್ ಟು ಮೇಕ್ ಶ್ಯೂರ್ ದಟ್ ಯು ಆರ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ದಿಸ್ ವಿತೌಟ್ ಫೇಲ್, ರೈಟ್? ಯಾ. ಸೊ ನಾವು ಇವಾಗ ಏನಪ್ಪಾ ಅಂತ ಅಂದ್ರೆ ಸೊ ಫಾರ್ ನಾವು ಯು ಆರ್ ಸಪೋಸ್ ಟು ಲರ್ನ್ ದಿಸ್ ಮಚ್ ಅಂಡ್ ನಾವು ಲೆಟ್ ಮಿ ಗಿವ್ ಯು ಸಮ್ 2 minutes of time to take a screenshot. You can just have a screenshot of this without fail, right? Yeah. Okay, so I'll just erase this. So ಏನಕ್ಕಂದ್ರೆ you have to learn all this is because if you get a situation like this you should know how to apply, right? ಇವಾಗ ನಂಗೆ ಬರೀಲಿ ಡೆಲ್ಟಾ ಟು ಸ್ಟಾರ್ ಇದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ನಾನು ಡೆಲ್ಟಾ ಟು ಸ್ಟಾರ್ ಮಾತ್ರ ಫಾರ್ಮುಲಾ ಹೇಳ್ಕೊಡಕ್ಕಾಗಲ್ಲ, ನಾನು ಸ್ಟಾರ್ ಟು ಡೆಲ್ಟಾಗೂ ಹೇಳ್ಬೇಕಾಗುತ್ತೆ. ಅಕಸ್ಮಾತ್ ಆ ತರನೂ ಬಂದಾಗ ನೀವು ಮಾಡಕ್ ಸುಲಭ ಆಗ್ಲಿ ಅಂತ ಹೇಳಿ, ರೈಟ್? ಓಕೆ. So right, and please to make sure that you start working for this from today itself, right? ಇವತ್ತಿಂದಾನೇ ನೀವು ಇದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಾ. ಸೊ ಎಷ್ಟು ಟೈಮ್ ಅನ್ನ ಕೊಡ್ತೀರಾ? ಸೊ ಹ್ಯಾವ್ ಟು ಗಿವ್ ಮೋರ್ ಟೈಮ್ ಫಾರ್ ದಿಸ್ ಅಂಡ್ ಲೆಸ್ ಟೈಮ್ ಫಾರ್ ಥಿಯರಿ, ರೈಟ್? ಥಿಯರಿಗೆ ಲೆಸ್ ಟೈಮ್ ಕೊಡ್ತೀರಾ, ಇದಕ್ಕೆ ಜಾಸ್ತಿ ಟೈಮ್ ಕೊಡ್ತೀರಾ. DSP ಗೆ ನೀವು 1 hour ಕೊಟ್ರು ಸಾಕು, half an hour ಕೊಟ್ರು ಇಟ್ಸ್ ಎನಫ್ ಫಾರ್ DSP, ರೈಟ್? ಎಸ್. ಸೊ half an hour ಟೈಮ್ ಕೊಟ್ಟು ನೀವು ಒಂದು ಮಾಡ್ಯೂಲ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ಸಾಕು, ಇಟ್ಸ್ ವೆರಿ ಮಚ್ ಈಸಿಯರ್, ರೈಟ್? DSP is not of this difficulty. So please do make sure that you cut short the time for DSP, you cut short the time for all the other subjects, and you give more time for this particular subject. ಈ particular subject ಗೆ ಹೆಚ್ಚು ಟೈಮ್ ಅನ್ನು ಕೊಟ್ಟಷ್ಟು ನಿಮಗೆ ಒಳ್ಳೆ ರಿಸಲ್ಟೆಂಟ್ ಬರುತ್ತೆ. ಸೊ ಥಿಯರಿಟಿಕಲ್ ಸಬ್ಜೆಕ್ಟ್ ಬಗ್ಗೆ ಒಂದು ಸಣ್ಣ ವಿಡಿಯೋನ ನಾನು ಮಾಡ್ತೀನಿ, ಖಂಡಿತ ಇಲ್ಲ ಅಂತ ಹೇಳಲ್ಲ, ಬಿಕಾಸ್ ಅದರ ಬರ್ಡನ್ನು ನಿಮಗೆ ಲೆಸ್ ಮಾಡಬೇಕಲ್ಲ. So I'll check through the theoretical subjects and I'll make sure that I'll provide you the important questions and how to write the answers for that questions, right? So ಈ ಸಲ ಸ್ವಲ್ಪ ಸಬ್ಜೆಕ್ಟ್ ಸಿಲೆಬಸ್ ಎಲ್ಲ ಚೇಂಜ್ ಆಗೋಗಿದೆ. ಸೊ ಸ್ವಲ್ಪ ಹಾಗಾಗಿ ಸೊ ನಿಮಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ನ ನಾವು ಹುಡುಕಿ ಕೊಡ್ತೀವಿ. ಅಂಡ್ ಅದಕ್ಕೂ ಮುಂಚೆ ನಿಮಗೆ ಯಾವ ಕ್ವಶನ್ ಪೇಪರ್ ರೆಫರ್ ಮಾಡಬೇಕು ಅಂತಾನು ಹೇಳ್ತೀನಿ. ಬಿಕಾಸ್ ಯಾರಾದ್ರೂ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ದೇ ಕುಡಂಟ್ ಅಟೆಂಡ್ ದ ಹೋಲ್ ಸೆಮಿಸ್ಟರ್ ಇನ್ ಅ ಪ್ರಾಪರ್ ಮ್ಯಾನರ್, ಅವ್ರಿಗೆ ಏನು ಅಂತ ಗೊತ್ತಾಗದೇ ಇದ್ದಾಗ್ಲೂ ಇಷ್ಟಾರು ಗೊತ್ತಾಗ್ಲಿ ಅಂತ ವಿ ಆರ್ ಟ್ರೈಂಗ್ ಟು ಹೆಲ್ಪ್ ದೆಮ್ ಔಟ್. ಸೊ ದಟ್ ಇಸ್ ವೈ ಪ್ಲೀಸ್ ಟು ಮೇಕ್ ಶೋರ್ ದಟ್ ಯು ಗೋಯಿಂಗ್ ಟು use this without fail, right? Yeah, just a minute. Okay, so yeah, I guess the syllabus got deleted. Just a minute. Okay, just a minute, students. I'll just so I guess the syllabus has been deleted by chance. So I'll make sure that I'll just get you the syllabus and tell you about the theory subjects also for you, right? Yeah. So now let me come to this, because ಅದನ್ನು ನಾವು ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಇನ್ನೂ ಬರ್ಡನ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ ಅನ್ನೋದು ನನ್ನ ಯೋಚನೆ. So that is why I plan to do a session for that, right? Yeah. So now let me convert the delta network to star network, right? See the delta network to I'm sorry, the delta network to star network conversion. If you do that, so you're going to get it as this resultant, right? So now if you consider your RA, this is one itself, I just showed you for the instance. So this is your RA if you consider, and if you consider this is RB, and if you consider this is RC, so then if you apply the delta to star transformation formulas, whatever I told you, you can just do the substitution side. RA, what is the first thing? RA, RB. If you do 1 into 2 divided by, what is 1 plus 2 plus 2? 1 plus 2 is 3. 3 plus 2 is 5, right? So if you do 1 into 2 into 5, and for R1, and for R2, if you do 2 into 2 into 5, and for R3, if you do once again 2 into 1 whole divided by 5, so this whole divided by 5 for R1, R2 and R3, so then you are going to get the resultants as it's nothing but 0.4, 0.8 and 0.4 respectively, right? Yes. So now if you do that, and then you are supposed to once again see through the network. Now again network got simplified, and this is the final simplified network. For this again you are going to apply the mesh analysis rule, right? Yeah. So if I try to apply the mesh analysis rule, so then what's that going to happen? So this delta to star transformation made me reduce the whole network into a simpler form, and now I got only two mesh, so I can easily solve this two mesh, right? Yeah. So my mesh 1 is nothing but V1 minus 0.4 I1, and it is plus 0.4 into 2 I1. Why 2 I1? Because in both the sides the current is flowing, and if you see the direction of the current, so the current is coming here, and for this also the current is coming here like this. So therefore it is I1 plus I1, which is 2 I1, right? So that is why it is 0.4 into 2 I1, which is equal to 0, right? And now here you can see that if you try to solve this, so what is 0.4 into 2? So 0.4 into 2 is 0.8, wherein you get 0.4 plus 0.8, which is nothing but, just a minute, 0.4 plus yeah minus 0.4 plus 0.8, wherein you are going to get it as 0.4 again. So you are going to get it as V1 plus 0.4 I1, which is equal to how much? It is equal to 0, and then now we get it as V1 is equal to minus 0.4 I1, and V1 by I1 is equal to minus 0.4, which is Z11, right? Yeah, I guess you got it how to do it. You are supposed to multiply 0.4 into 2, you get 0.8 I1, and if you subtract these two, you are going to get plus 0.4, and after that you are going to do the resultant. So here also it is the same. What is here? It is nothing but a V2. You are going to start from here. So it is V2 minus 0.8 I1. So once again it is plus 0.4 into 2I2. Here it is plus 0.8 into 3I1. Why plus 0.8 into 3I1 is because here there is a current, that is 3I1, which is flowing through 0.8. So therefore it is nothing but plus 0.8 into 3I1 and 3I1 plus 0.4 into, it is nothing but plus 0.4 into 2I1. So which is equal to what? So it is equal to 0, right? This is what is one important thing. And now here is supposed to simplify this. Once again 0.8 into 3I1 is 2.4 I1, and 0.4 into 2I1 it's 0.8 I1, and you're supposed to now get it as, so that is 2.4 plus 0.8 is nothing but 3.2, and now you get V2 plus what I can say, the 3.2 I1, which is equal to once again 0, and if I shift this over here I am going to get it as V2 minus 3.2 I1, so which is equal to 0. I'm sorry, V2 is equal to minus 3.2 I1, not equal to 0, I'm sorry, 3.2 I1, and your V2 by I1 is equal to minus 3.2, which is Z21, right? Yeah. So now we want to find Z12 and Z22. What is Z12? Z12 is nothing but V1 by I2 for I1 is equal to 0, and your Z22 is equal to what? Your Z22 is equal to V2 by I2 for your I1 is equal to 0, right? So this is what is one important thing. So now let me try to solve this out. So if I try to solve this out, so I'm going to get it as this resultant circuit. Once again, I have to take the basic circuit, whatever I have, the question that is given to me, and for that I am going to what? So for that I am going to eliminate I1. That is, I am going to make my I1 is equal to 0. So here my I1 is equal to 0. So this 3I1, that is dependent source, will become open circuited, and here also my I1 will get eliminated, right? Yeah. So now what's that going to happen? Start. So here you are supposed to once again use what? You are supposed to use the current divider rule, right? No need of converting a star to delta. It is because, so if you do that once again, you are going to apply the mesh analysis rule like this. So that is not at all required, because here there is an open circuit, and here my I1 is 0. So please use the current divider rule, right? So that is my I2 into. So I consider that here current I4 is flowing over here. So I'll consider that my I4 is equal to what? The current, that is I2, which is flowing over here, that is into 2. What is 2? So this is 2, which is my, this is 2, R2, I'm sorry. This is 2, which is my R2. That is whole divided by, this is 2. That once again this is R2, that is 2 plus 1, which is 3, right? It is nothing but my I2 into R2 divided by R1 plus R2 is my formula, right? Yeah. So for this formula, if I try to apply, so my R2 is 2, which I have applied, and here also my R2 is 2, which I have applied, and here it is 2 plus 1, which is equal to 3, right? That's one resistance. So now if I do that, I'm going to get 2 by 5, which is equal to 2 by 5 I2, which is equal to what? So it is equal to here 0.4 I2, right? You got the resultant now, right? Yeah. So now we want V1. What is V1? V1 is equal to I4 into 1, because my V1 voltage is across this resistance 1 ohm. So that is why I'll take it as V1 is equal to I4 into 1, wherein my I4 is 0.4 I2, and this into 1 will be the same, right? Into 1 will be what? Into 1 will be 0.4 I2. According to this V1, So here I4 is flowing over here in the voltage V1, as well as there is a 1 ohm resistance wherein the voltage V1 is across that 1 ohm resistor. So therefore you are going to get it as that is I4 into 1, which is I4 is 0.4 V1, I'm sorry, 0.4 I2 into 1, which is equal to 0.4 I2. So now I got V1 by I2 0.4, which is Z12. What is V2 by I2? So it is nothing but this 2 into 3 divided by 2 plus 3. That's nothing but a general, what I can say, the current, that is current and resistance in parallel. I'm sorry, resistance in parallel. So that is this 2 into 3 divided by this 2 plus 3. So you're going to get it as 1.2 ohm, which is Z22. Right? Yeah. So now let me take the y parameter. So according to the y parameter, this is what is the equation, that is I1 is equal to y11 v1 plus y12 v2, and I2 is equal to y21 v1 plus y22 v2. So this is what is my general equation, right? So now according to this, your y11 is equal to I1 by v1, for your v2 is equal to 0, and your y21 is equal to I2 by v1, for your v2 is equal to 0. So now if v2 is equal to 0, that means if any the voltage is 0, so what is it is supposed to do? What is it is supposed to do is the voltage will become short circuited. So if your current is 0, it is open circuit, and if your voltage is 0, it is short circuited. So you need to know this, right? I have already told you with respect to the I'm so sorry. So if you have an voltage is equal to 0, then it is an open circuit. I'm sorry, short circuit. And if you have a current is equal to 0, it is an open circuit. We have already discussed in Thevenin's and Norton's rules, right? Yeah. And we have also discussed with respect to superposition theorem also, right? Yeah. So now here you can see that. So now here you can see that, so it is nothing but, now I got this resultant when I made my V2 is equal to 0. So now I can't apply mesh. So I'll apply node analysis, which is, so I'll just take another color to mention the nodes over here. Okay. Yeah. Okay. So see here it is one node. This is my node 1. And this is what is my node 2, right? I have highlighted the nodes over here, and already they have numbered it as node 1 and node 2 respectively, right? Yeah. So now here at node 1, so what is my current here? It is I1. The current, it is minus V1 by 1. So this is my V1 divided by 1, because here voltage V1 is here, right? Here at this point the voltage is V1, and at this point the voltage is V2, right? Yeah. So now it is V1 by 1 minus this V1 minus V2 by 2. I have already told you if there is any resistance between the two nodes, so you are supposed to take that particular node, and you're supposed to divide the two nodes by the given resistance, right? So one ಎರಡು node ಮಧ್ಯೆ resistance ಇದೆ. This is one node, that this is V1 node having voltage V1, and here is one node having voltage V2, and if there is any resistance in between this, so you are going to subtract the V1 minus V2 by 2, right? V1 minus V2, that is whole divided by, you are going to subtract the voltage of those nodes divided by the resistance which is present between the two nodes, right? Voltage of two nodes, right? That is what is we have done it over here, which is equal to 0. Now you know that my V2 is equal to 0, right? Yeah. So if I make my V2 is equal to 0, so 0 by 2 is 0, so I get my V minus V1 by 2, which is equal to 0. That's nothing but here. So if you subtract this minus V1 by 2, what you get? You get 1.5, right? If you solve that, you're going to take 2 as common over here, wherein I guess this is very much light for you. I'll just take a black color itself. Here you are going to get 2 as common, wherein this is minus 2 and this is minus 2v1 minus v1. So wherein you are going to get it as minus 3v1 by 2, or you are going to get it as minus 1.5 v1, right? So this is what is the simplification of this whole thing, right? Yeah. So now just a minute. Okay, so this is what is one important thing. And now here, after simplification of this particular, you got this resultant. So now we are supposed to write it as what? Is supposed to write it as that as I1 minus 1.5 V1, which is equal to 0, or I can write it as my I1 is equal to 1.5 V1, or my I1 is equal to what I can say, I1 by V1. Just a minute. So it is nothing but my I1 by V1, which is equal to, that is 1.5 ohm, which is nothing but your Y11, right? You are supposed to write it ulta, right? Not like this. So in the case of Y parameter, you are supposed to write this ulta, it's admittance parameter, right? See, you can see here it is written ohm like this, but there you are supposed to write it ulta, right? Yeah. So now let me take the second one. So for the second one, for the node 2, my current flowing is I2 minus 3I1. Why? Here the current I2 is flowing and here there is a 3I1 flowing. So both joins together and you get it as I2 minus 3I1. So this I2 minus 3I1 gets divided into 3I1 and I2. Here there is a point wherein two current meets. So that is nothing but your I2 minus 3I1. Right? Yeah. So now here it is I2 minus 3I1. So here it is plus what? Here it is plus V1 by 2. So what is V1 by 2? So once again, just a minute. I'll just check it out. Right? Yeah, it is V2 by 2. I'm sorry. It is minus this V2 by 2. And once again it is minus V1 minus V2 by 2. Right? So that is what is you're going to get it as 0. It's plus V1 minus V2 by 2, which is equal to 0. Right? So I2 minus 3I1, how did you get? I told you there is a two currents is flowing here and the combination of two currents is I2 minus 3I1 and here it is minus V2 by 2 and it is plus V1 minus V2 by 2, which is equal to 0. You can also take it as minus V2 minus V2 minus V1 by 2 also you can take, it is up to your wish, right? Yeah. So it's equal to 0 and if I try to simplify this, I'll get it as this because my V2 by 2. So 0 by 2 what? 0 by 2 it is equal to 0 by 2 it is equal to 0. So now I get it as I2 minus 3I1. So that is plus V1 by 2 which is equal to 0. Right? It's plus V1 by 2 which is equal to 0. And then now if I try to substitute I1, what is my I1 I have got? I have got as 1.5 V1. So if I try to multiply this 3 into 1.5, so what you're going to get? If you multiply 3 into 1.5, you're going to get it as 4.5, right? Yeah. So you're going to get it as 4.5 and now you're going to get it as that is minus 4.5 I2. So you're going to get it as minus 4.5 V1, right? Yeah. Here it is nothing but I2 minus, just a minute, I'll just erase this off. So yeah. So here it is nothing but I2 minus 3 into 1.5 is nothing but minus 4.5 V1, right? It is plus V1 by 2 which is equal to 0 and if you simplify with respect to this you are going to get it as I2 by V1 is equal to 4 ohm, right? It is ulta, right? It is admittance, right? Yeah. So now here how do you get this is that you are going to do minus 4.5 V1 plus V1 by 2, right? If you do that, so you're going to get it as 2 over here and here it is what? So 2 into minus 4.5 is what? So 2 into minus 4.5 will yield you to minus 9, right? Minus 9 plus V1 minus 9 V1 plus V1 by 2, right? Yeah. So now you get it as what? It is nothing but minus 8 V1 by 2. So what is 8 by 2? This is 2 ones are 2 fours are, right? So that one we have written it over here, that is 4, right? So now you get it as I2 minus 4 V1 which is equal to 0 or I can say that as my I2 is equal to 4V1, or my I2 by V1 is equal to 4. That is this one, Y21, right? So now if I make it as V1 is equal to 0, the network in figure 7.12 may be written. So I'll take the original diagram. So in the case of original diagram, I'll make this V1 as completely 0. That means that I'll make my V1 as a, short circuit, right? If I make my V1 as a short circuit, then what is that I'm going to get? So what is that I'm going to get is the same circuit and the same node equations, right? So see here, please do make sure that when you make your V1 as 0 also, you're going to get the same node equation without fail, right? So let me consider the same node equations, and now what I'm supposed to do is that I'm going to take my V1 as 0 in that node equation, right? In that node equation, I have V1 also and V2 also, but in the first case, we took V1 as 0, V2 as 0, I'm so sorry, but in the second case, let us take it as my V1 is equal to 0. If I take my V1 is equal to 0, so what's that equations I'm going to get? So what is that equations I'm going to get is nothing but, so just a minute. Yeah. So what is that I'm going to get if I take my V1 is equal to 0 over here? So it is nothing but you're going to get it as that is I1 minus V1 by 2. The same node equation, students, because if you go back to the diagram and look at, so this is the same node equations you get because same nodes are present, see, right? So that is why the same node equations and no changes in the node equation. So please to make sure that you're going to know that, right? Yeah. So now if I consider that, so now here there is a small change only in the second node equation, students. All the same in the case of first node equation, but in the second node equation there is a change. I am going to tell you that, right? See here, this I1 minus V1 by 2, right? Minus V1 which is equal to 0. So now if you simplify this particular part, you are going to get it as I1 minus, what is that? So it is 2, and this is minus V1, so it is minus 2v1, right? So you are going to get which is equal to 0, and it is nothing but what I can say. So if I write it in terms like this only, just a minute, I'll write it in a proper manner. Yeah. So it is here, it is v1, here it is minus v1 by 2, right? So I'll consider this 2 over here, and it is minus 2v1 minus V1. So what I'm going to get it as? I'm going to get it as 3V1 which is equal to 0, right? So you're going to get it as what? So you're going to get it as that is, just a minute, I'm going to clarify this. So here I'm going to get it as 2V1 minus V1. So wherein I'm going to get it as what? I'm going to get it as V1. So just a minute, students, I'll clarify. So here it is nothing but, so you're going to get it as her. So here it is V.